In the previous video, we had a look at drawing the graphs of y equals a times f of x and y equals f of x plus d, just from the original graph of y equals f of x. And if you remember, those both made vertical changes to the graph. Where we had y equals a times f of x, we got a stretch in a vertical direction. So the turning points didn't move along the graph or anything, the whole graph was stretched up and down the way. And where we had the graph of y equals f of x plus d, the whole curve just moved up or down. So today we're going to have a look at something different. We're going to have a look at the graphs of y equals f of x plus c and the graph of y equals f of b times x. So this time the changes are inside the brackets. We are changing what we're putting into the function. This is the original function, f of x, the graph of the original function. And what we can see from this graph is that f of 0 is minus 1. F of 1 is 3. And f of 3 is minus 1. But I want to draw the graph of f of x plus c. So we're putting in x plus c into there. I'm going to set c equal to 3 just now. Let's think about what we know already. We know that f of 1 is 3. But if we choose x equals 1, this becomes f of 4. Well, we don't really know anything about f of 4. We could look at the graph and say, well, it's probably 3, but we haven't been told that. What we really want to have going into this function is 1, because we know for sure that f of 1 is 3. So let's say, well, we want to put 1 into the function. So let's say x plus c must be 1. We want to put 1 in that function. Now if x plus 3 is 1, then you have to set x to minus 2. So if we set x to minus 2 and then add 3 onto it, we get 1. And we know that f of 1 is 3. So this point, this 3, this peak of the graph, actually doesn't occur here anymore. It occurs where x is equal to minus 2. So it occurs here. You can see it's moved to the left by 3 units. Let's think about this point here. Now this is our original graph. It tells us that f of 0 is minus 1. So we want to put 0 into the function, and we know we're going to get a y value of minus 1. So if we put 0 into this function, we need to set x plus c equal to 0. Now, we've got c set to 3, so we need to set x to minus 3. Then we'll have f of minus 3 plus 3, f of 0. We know that's minus 1. So at x equals minus 3, we get f of 0 equals minus 1. So at x equals minus 3, we're going to get this y value of minus 1. So again, you can see that this point has moved 3 units to the left. And of course, the same will happen with this point and with every other point on the graph. And in fact, if I switch this on so you can see what's happened, the whole curve has moved to the left by 3 points. So it does the opposite of what you might expect. If you add something on inside these brackets, the curve moves to the left. Similarly, if we add on a negative number inside those brackets, it moves to the right. So it's just worth remembering that if something changes inside the brackets, it does the opposite of what you would expect. So we've had a look at the graph of the function y equals f of x plus c. Let's think now about the graph of the function y equals f of b times x and see what happens to that. Here's our original graph, the graph of y equals f of x. And this point here tells us that f of 1 is 3. So let's make use of that information. We know that f of 1 is 3. So this peak is going to occur when we put 1 into the function. Let's set b equal to 2. So we want f of 2 times something, and we want that to be 1. So we're going to need to set x equal to a half, and then we will have f of 2 times a half, that's f of 1, and we know that's going to be 3. So this peak here is actually going to occur when x equals a half. It is going to occur here. Let's have a think about this point here. We know from our original graph that f of 3 is minus 1. So in order to get this trough, this minimum turning point here, we need to put 3 into the function. Well, we've got f of b times x. So we've got f of 2 times x, but we want this 2 times x to be equal to 3. So we're going to have to set x equal to 1.5. So that we're putting in f of 2 times 1.5, which gives us f of 3, which gives us minus 1. So this trough is going to occur when x is 1.5. It's going to occur over here. Let's have a think about this point here, point A. We know that f of 0 is minus 1. Now, b is 2. We want to put 0 into this function. So we're still going to have to use x equals 0. So that point there doesn't move. So let's have a look. We'll switch this function on so you can see it. And you can see that what's actually happened is that the curve has been squashed. It's half the width that it was before. This minimum turning point is half the distance from the y-axis that it was before. This one is half the distance from the y-axis. And as we increase b, you can see that that gets smaller and smaller. When b is 3, the width of the curve has been decreased by a factor of 3. Let's see, if I set b equal to a half, that actually doubles the width of the curve. The peak used to be at x equals 1, and now it's at x equals 2. And of course that is because if we put x equal to 2 into here, we're taking f of a half times 2, which is f of 1, and we know that f of 1 is 3. So again, it does very much the opposite of what you would expect. And there's one more thing we really need to look at here. Consider what will happen if we set b equal to -1. So we are taking the graph, we want to draw the graph of y equals f of negative x. We know that f of 1 is 3. So really we want to put 1 into this function. But we're taking f of negative x. So we need to set x equal to -1. So that what we're putting into the function is +1, and we know we're going to get 3 out of it. So this peak will occur when x equals -1. Let's look at this point here. We know that f of 3 is -1. So we want to put 3 into the function. So we want b times x to be 3. Well, b is -1, so we're going to have to put in x equals -3. So that what's inside these brackets is -1 times -3, which is 3. And f of 3 is -1. So if we put x equals -3 into the function, we get -1. So if I switch this function on so that you can see it, you can see that what's actually happened is the function has turned back to front. It has been reflected in the y-axis. And that perhaps is what you would expect it to do. So that is kind of an exception to this rule. If something's inside the brackets, we've got a negative value, we get a reflection in the y-axis. Of course, if I make that -2, we get the reflection in the y-axis and the compression, the squashing of the curve. So again, once we start getting into negative numbers, what we're going to find is that the graph will be reflected in an axis. If the negative number is inside the function like this, it's going to be reflected in the y-axis. So it's a horizontal flip. Whereas in the previous video, if the negative number was outside the function, it turned the curve upside down. So it was a vertical flip. We will have a look in the next video at how to actually do an exam question about transformations of graphs.